So this one wants us to find the domain and range of these nice relations here. So the first thing it asks you to do is determine whether or not it's a function. So we should do that first. And we know that a function, what that means is for each input, which is an x value, there's only one y value. So if we look at the first one and we want to decide whether or not this is a function, we need to see if each and every x value that is included in the ordered pairs here in this little circle, if each and every x value is paired with only one y value. So we can kind of see graphically what we're doing here with this vertical line test we probably heard about, because if we can exhibit two x values that share the same y value, that means that they're on a vertical line. So if we can intersect this thing with a vertical line anywhere, that means it's not a function. So hey, this one's not a function, and the instructions just tell us to write none in the domain and range, and this is not a function. So there's a little circle you put a dot in for the not a function, and domain and range will put none. I probably did that in the wrong order, but I think we get the idea. All right, so this one is a function because we can't do this kind of idea. So if we were to take any vertical line anywhere, it's only going to ever intersect it at most one spot. So that means that this is a function. That's how we verify it graphically. Anyway, so we did decide this is a function. How wonderful function. Okay, now we just have to say what the domain and the range are. So the domain looks like they want it in interval notation. So good, that's a convenient notation. So domain, these are all the x values. So if we're looking at all the x values, we want all of the x values for all of these ordered pairs. So we're not going to include that point. We are going to include this point and everything to the right of it. Essentially on a graph, what we're looking at, if we're only interested for the domain, all the x values. So if we squished everything down to this axis, we're only going to be touching here and left, right? And we're going to be touching here and right. So when we're trying to say what our domain is, it's this interval union this interval. So that's all the x values that are there. So we can write that. The left end of this is negative infinity, and then the right end of this is 1, 2, negative. We do not include it, so that's a parentheses. We never include infinity because that's not a real number. So that always gets the parentheses. And then we want this other junk too. So we want union, or these other values, rather. I probably shouldn't say junk. Anyway, so union, this other interval. So we start at 1, looks like we do include it. And then we go all the way to infinity. So there's our domain, happy days. Let me do a different color for the range if I'm going to draw something with that kind of idea. So if I want to do my range, we can do the same thing. If I squish everything to the y-axis, then I'm just going to have this point and down, all the way down. And if I squish all this just to the y-axis, because that's really all we care about for range, we're going to have this interval. So now we can look at these. So we're going to, again, have the union of two intervals. They're going to be a little different looking, but they're all, we can do it. Okay, so this interval would be negative infinity all the way to 0. And we would include 0 because we got a closed dot there. And then we're going to have a union and then the rest of it. So 3 on up. So we've got 3. We don't include 3. We go all the way up to infinity, and we don't include infinity. All right, so functions, domain and range. We did it.